Hey everybody, welcome to this lesson on your A+ 1202 prep. At this time, we are looking at exam objective 1.9. We're going to do all of the Linux commands and give you information on what you need to know about the Linux system as well. Specifically, commands you can see on screen here, and then I'll tell you about these files and these OS components, and I'll give you a really simplified, easy to understand overview of everything. And at the end, I will also give you some practice questions so you can make sure you have an idea of how ready you are for the real thing. My goal here is to make all of this as simple as possible, so stick with me, I'll get you through it. This video, I'm actually going to pull a lot from my 1102 series. A lot of this is the same, so I'm going to pull in an old version of me to explain some of these commands, and I'm going to be here to explain the new commands that they want you to learn as well. All right, so with that being said, before we get started, if you're new here, my name is Matt, and my goal on this planet is to help you guys pass your A+. I help this person pass their test today with my notes. I help this person get almost full marks, and they're moving on to Network Plus. This person passed their Core 1, moving on to their Core 2. This person passed their Core 1 as well. So stick with me and I'll try my best to make sure this happens to you as well. So that being said, I'm going to pass you guys over to old Matt for those other commands, and then I'll come in when I need to. The first one is essential navigation, right? That's all I want you to look at right now is just where my mouse is. So the first one is ls, which is an essential navigation command. It's going to allow us to navigate across our Linux device through the command terminal. So basically what it does, you can have a read of that, but just in plain and simple terms, I'll open up my virtual machine here. What it does, I'm in my Linux virtual machine. I highly recommend you get one. I will do a video directly after this giving you a quick tutorial of how to download that, so that way you can actually go about practicing this. But all it does, if I type in ls, it will simply show me what is within my current directory. So whatever directory I'm currently operating in, it will show me what is there. So I have the blue ones are all directories that are within the directory that I'm currently in. Take a shot every time I say the word directory, right? So I have desktop, downloads, pictures, etc. within my current directory. And then there is an executable file. I can tell it's executable because it is green here as well. So it basically tells me what is there for me. That brings us to the next command, which is here, print working directory, or pwd. And essentially this is doing something similar here. So it's a navigation command. If I type in print working directory, it will simply show me where I am currently within my system, what the current directory is in my system. So if we stop to think about it, maybe I'm in my system, I've just opened it up, I don't know where I am, so I need to know. I might type in pwd, print working directory. Oh, okay, I'm in home and Ubuntu. Okay, so what current files do I have within my directory? I would then type in, to find that, ls. Okay, so I'm in home, I'm in Ubuntu, and these are the current directories and files that I have in my current directory, right? With those two commands, that is the information I have gathered. ls tells me what is in my current directory, and print working directory, or pwd, tells me what directory I'm currently operating in. Now, this brings me to file manipulation. So MV is going to allow me to move or rename files and folders. So move or rename. So let's say I want to move this file. I want to move this file, test text, into, let's say, desktop, for example. So let's go ahead and go MV test text. And a quick tip for you, if I didn't want to type that whole name of that file out, I could start typing it, so test, and then hit the tab button. It will automatically fill it in for me. And I want to move that to the desktop directory, which is over here. I'll hit enter, and okay, nothing seems to have happened, right? But if I list using ls, you'll notice that, okay, now the test text document is gone. Now, I'm going to go into my desktop directory here. Funnily enough, this command I'm about to use isn't actually on the exam objectives, but really you should know how to use it. I'm just going to use it and go through it with you. To go into the desktop directory, I'm going to use cd desktop. Okay, I'm now in that directory. And now if I list my current, if I ask it to list the files and directories in my current directory, you'll notice that I have test text within that directory, right? So I have successfully moved it. Good stuff. Now I've just undone what I did there, and I've moved the test text directory back to where we were because I want to show you the next command. And that next command that we're going to be having a look at is the cp, or the copy. It's basically you're copying a file or a folder, right? So it's similar to move, but you're copying. So in this instance, if I just go back to the desktop, just to show you, oops, I had caps lock on. There's currently no test text in there. So if I go back to where I was, I want to move test text, or I want to copy test text into desktop. I would simply use the command copy, or cp test text. I'm hitting tab to autofill that once I've started typing, and I'm going to copy that into desktop. All right. Again, if I list, test text is still here, and if I change directory into desktop and list, it is now also there, right? So that's great, but maybe I don't want it there, and maybe I want to just remove that copy. That brings me to the rm command, or the remove command, which, as we can see here, is simply removing a file or folder that we have created. So in this instance, I'm within the directory I want to remove this from. I would just say rm test, whoops, case sensitive. It is caps, case sensitive, test text, and I would then list it, and we can now see that it is gone. It's not there anymore, right? So I'll change directory back to where we came from, list. That's what we have available in our current working directory. So we're currently in home Ubuntu, and these are the files and directories that we have currently working for us there. That's going to bring me to the next command that we need to know in the order of the exam objectives that they are presented in, which is relating to permissions and ownership. So the first one we need to know about is chmod, or chmod, or chmod, or however you want to say it. But basically what this does is this command modifies file permissions. So it's controlling whether you can read the file, whether you can write to the file, or whether you can execute the file, or what combination of those you can do. So I'll show you what this looks like in the system, and then I'll explain it a bit further, because this one can be a little bit confusing. But essentially, if I just use the regular list command, ls, I only get this information. I see what documents and files are available. But if I use a flag, if I use an additional command on top, so ls, then I'll give a space, and I do -l, so ls-l, it will give me some additional information here. And that additional information that is relevant to us for this one is we've located our test text document that we have there, but we also have this thing over here. What are all these random letters? This is telling us whether we can read, whether we can write, or whether we can execute the file. The first one is the user, or the owner of that file. The next one is the group, so the group that file kind of belongs to. And the next group of three is telling us what other users can do, what all other users are able to do with it. So if it says RWNX, that means you can read, write, and execute. Now, let's say, for example, we want to make it so that the owner of the file can read, write, and execute. We want to make it so that the group can read and write, and we want to make it so that the all other users can only read it. There is a method to do it, and before I show you what the command looks like, I do need to show you, just go quickly through something with you. So this is where it gets kind of complicated here, but just stick with it. You'll get your head around it, trust me. Each command has a number given to it. So read equals number 4, write equals number 2, and execute equals number 1. So if you want someone to only be able to read and write, that will essentially mean you're going to say 4 plus 2, which is 6, right? So if I give the number 6 to a user, the owner of that file is only going to be able to read and write. But 4 plus 2 plus 1 is 4, 5, 6, 7. They'll be able to do everything. But if you only give them a 1, they'll only be able to execute. You understand? So depending on what you want them to do will depend on what number you give them. So I'll show you what that looks like in real time, and it might make a little more sense. So for example, let's say that I want No, I want everyone to have every single permission here. So I would say chmod. Now, if we look at our numbers, remember they all add up to 7. So 4 for read, 2 for write, and 1 for execute. 4, 5, 6, 7. So 7, that first number is going to apply to the owner. 7, the next number is going to apply to the group. And 7, that one is going to apply to all other users. So in this instance, everyone can do everything. And then I just specify the text or the file that I'm doing this to. So test text. Okay. So now if I do list with L, you can see everyone can do everything. But maybe I want to change that. Maybe I want to say, chmod, I want the owner of that file to be able to do everything. So I'll give them a 7. I want the people in that group to be able to read and write, but not execute. Okay, let's have a look at what I'd have to do. Read is 4. Write is 2. 4 plus 2 is 6. So I'm going to give them a 6. And finally, other users, I only want them to be able to read. So I'm going to give them a 4. I give a space. I specify the file I'm talking about. ls-l. Let's see if I did that right. Okay, so the first 3 is the owner. So read, write, and execute. That's right. The next one is the group. The group can now read, write, but there's a dash there so they cannot execute. And other users can only read. They cannot write or execute. So that worked out well. So try to get your head around that. Just the number system and how each number is given to a particular level of access there, and then you'll be sweet. And just understand the format of that command. Okay, the next one is chown or chone or cone or however you want to say it. Basically, you're changing the owner of a file. So let's say I wanted to make me, Matt, own that file. I would say chone space Matt space, and then I would just specify the file. Now, this is a virtual machine that I have downloaded and installed on VirtualBox. So I haven't set up all the users or anything, but that would, in theory, make me the owner of that file. It's as simple as that. We also have grep. So this is about text. So to grep is you're essentially searching for a certain thing within a certain line or certain phrases within a text file, for example. So let's have a look at what that would look like. I have this text file that we have been looking at. So test text is my text file, right? So don't worry about this command for now. We'll get to it in a second. But this is the full text file. If I ask this to print out my bad. If I ask it to print out, the text file reads, hi, this is one line. However, this is another line. Okay, great. So I might only want to, let's say this is a huge text file and I'm trying to find something specific in there. I might only want to find the word however. So in that instance, I would say grep however test text. And then it only prints the relevant line and it highlights that specific word that I'm searching for. So you can imagine maybe if you were searching through a wide variety of numbers and you were looking for a specific IP address, how that could be useful. Similarly, if I said grep hi, then I specify the file I want to search. See how it highlights everywhere where H is followed by I. So it's highlighted both lines and it's shown, it's highlighted that the specific areas that I'm looking for. So you can see how that would be useful if you're trying to search through a large variety of information. I can imagine you would be able to see that. I hope you can see how that would be useful. You also have find, which locates files based on various criteria, such as your file name, modification date, or file permission. So if you're looking for a specific file or they're created on a specific time or date, you would use the find command. We also need to know about the fsck command. So on Linux, what this is it's kind of like the equivalent of on Windows. If we remember back to, I think it was exam objective 1.5, we had the sfc/scan now command, which scanned for any corrupt system files, right? So in the same way, the fsck command stands for file system check, is how I want you to think of it. File system check. We're checking through all of the file systems that we have and looking for any issues, and if we find those issues, we're going to repair those issues. And you have some specific commands or flags that you can use to put on top of this command. So first thing I want you to understand is the fsck command. You are going to use this to check and repair your Linux file systems. Functionally, 99% of the questions you will get what you're going to have to do is just simply say, oh, the command you use to check your Linux file systems is fsck. That's 99% of the time going to be how deep you have to go. But just in case we need to go further, you can also do some additional commands here. You can do fsck with the flag Y, which will automatically assume yes to repair prompt. So what that means is every single time it comes across something that needs to be repaired, it will do it automatically without prompting you. Additionally, you can do fsck flag F, which will force check even if the system appears clean. It will just check anyway, even if there's not necessarily anything that it found out of place. So it'll force that check. Next thing we need to know is the mount command. All right, so the mount command essentially attaches file systems to your directory tree. So I'll give you a verbal overview and then I'll kind of show you what this looks like. So mounting, what does that mean? It's essentially taking a device of some sort, generally a storage device. Think about a USB, for example, and it is allowing that device to be accessed on your system. Long story short, that is what that means. So let's go ahead and have a look at my Linux virtual machine here. If I type in the command mount, it's going to show me my current mounting configuration setup. So if I go up to the top, this is where I put the command in. I just said mount. This is going to tell me that sysfs is mounted on /sys, all right? Or proc is mounted on /proc. udev is mounted on /def. So on my system tree, it's telling me exactly where all of these things are mounted. And if I want to mount a USB, generally a lot of the time this kind of stuff happens automatically, but if you wanted to manually do this, you could use the mount command. So let's go ahead and look at some of the flags that we can use. So if we want to mount in read-only mode, you're going to use the command mount with the flag O followed by RO for read only, which will mount in read-only mode. So the people can't actually write or execute on that, right? Similarly, mount with the flag A will mount all systems in the file etc fstab. We're going to have a look at what that means in a second. Don't worry about that too much. Functionally, guys, what you need to know is if you want to mount a disk or a storage device, you're going to use the mount command. 99% of the time, that's what your question is going to ask you, so I don't want you to freak out about this too much. Your question is likely going to say something like, which command is used to place a storage device within your current device's tree so that it is accessible, which is just a fancy way of saying which device is used to mount a USB onto your device, and you would use the mount command. And the reason they would phrase it in a funny way like that is so that the word mount isn't in the question, because that would make it too obvious, right? But just understand when you would use the mount command and you will be fine, guys. Trust me. Okay, the next one is su or sudo. All this does is it allows me to basically run my commands with full privileged access. So if I wanted to run a command, I would simply type in sudo space, and then whatever command I run, I'm now running with administrative privileges. All right, so that's all sudo does. And then we have package management. So package management, basically, this is how you update your system, download and install software, things to that effect. And which one of these is going to depend on which version of Linux you have. So if you have a Debian based system, you're going to be using apt-get. You do also need to know about the dnf command. So just a quick rewind, the apt command is for packages on Debian-based distributions, and the dnf command is the same thing as the apt command, but this is for packages on RPM-based distributions. So for your exam, essentially just know, it might ask you, how do you install something on, and that might say Debian-based system, or it might say RPM-based distribution. If it's a Debian, you're going to know it's going to be apt, and if it's a RPM, you're going to know it's going to be DNF. Functionally, that's the difference. One is apt, one is DNF, but they both do pretty much the same thing. Now, the next command we need to know is the IP command. The first command we need to know related to this is IP address show. That will show us things to the effect of our loopback address, our IP address, things like that. But we don't always have to type that in. We can actually abbreviate that to IP A, and it will give us the same information. That's our loopback address, our own IP address. You can also use the IP address to show your routing table, to show how data is routed. So you can say IP route show for that, which will give you some information, right? So the default route is via this IP address, etc. Right? Yours will probably be a little bit bigger. I'm using a virtual machine, which is a little smaller, which changes it a little bit. But functionally, what you need to know is that the command IP A will show you your own IP address, your loopback address, and those basic that basic information. And the command IP route show will show you the IP routing information there as well. You can have a quick read through of what I have here on a learning guide about the command as well, but we're going to keep this thing moving for the sake of efficiency. We are onto the ping command. We do need to know ping for Linux as well. Good news is it's the exact same as Windows, so really I shouldn't need to go over this too much. If you've done the previous exam objective, let's go ahead and use ping, right? We know what ping does. Ping is a simple message we're sending out just to see if we can actually, if we have any amount of connectivity. If I wanted to ping, let's say I want to go ping 8.8.8.8, I will hit that command and it's just going to start sending out some pings, and it's going to tell me whether or not they come back and the time in which I receive those back. So it's a simple way to say, hey, can I connect to this thing? Can I send that data? And can I also receive data from this particular device or IP address that I am trying to send data to? And it will send me all of this, and it will just keep going until I say, hey, stop that. So it'll give me information. I transmitted 23 packets. I received 23, so I had 0% packet loss. All right, so basically I now know I can reach out to that particular IP address, and I can also get information returned to me from that IP address, so I can successfully communicate. Generally, you're using ping if you want to see, hey, can my device actually reach an IP address within my network? Or similarly, can my device reach an IP address outside of my network? That's really when you're using ping. If you need any additional information on top of that, that's when we would want to use the other commands that we're going to be talking about in a second. But I do want to do this in the same order as the exam objective. So next we are going to be looking at the curl command. So long story short, a curl command is a way of retrieving information from a website through the terminal, through our text input. We are not going to be clicking on Google and typing in and going to the website, right? So let's say, for example, if I wanted to go to journeytocyber.com because I wanted to get my hands on an amazing learning guide that will help me pass, right? Instead of going in and manually typing that in, I could go to my Linux virtual machine. I could come to the command prompt and I could type in the command curl. If I just type in curl, it's going to ask me to do something additional, right? So what I need to do is type in curl and then the specific human readable URL address of the website that I want to reach. So in this instance, I would say curl https://www.journeytocyber.com, enter. And then it's going to give me a whole dump of information. And this is essentially the code from my website. So if you want to access journeytocyber.com and see what code I have on my website, you can use curl. And then you could further use the commands such as grep to search for specific information here. Okay, we've talked about grep. All right, so grep is a tool that you would use to search for particular text within a clump of information. So curl will allow you to retrieve that information, and then you can use other tools to do something with this information or find what it is you're looking for. But just know, specifically, all you need to know is that curl is used, oh my goodness, curl is used to retrieve information from a website. Functionally, that's really what you need to know. And then you've got dig. So dig, it's basically the NS lookup, but for, what am I on? Linux. It's NS lookup, but for Linux. So if I wanted to find out something about Google, like the IP address of Google, I'd say dig google.com. Or if I wanted to find out journeytocyber.com, I would say dig journeytocyber.com. Okay, cool. So I've now got the IP addresses of journeytocyber.com. I hear they have great learning resources for the A+1101 exam, but moving on. Now we're on traceroute. Good news here, guys, is traceroute on Linux is the exact same thing as traceroute on Windows. So ping, that prior command that we already know about, is the one that does a simple send a message, receive a message. But traceroute, as we talked about previously, doesn't only send a message to the final destination and report on data relating to that. It will send us data relating to every step along the way. So just as another visual representation, just so we can go through this again, with ping, what we're doing is we've got our device. Oh, let's maybe we'll use this one. We have our device here, and we have our destination device that we want to send a packet to, a packet of data. Ping will simply go, all right, I'm going to go, how long did it take me to do that? And how long did it take me to retrieve that? That's the information I get. But it doesn't give us any information relating to the many different stops that data had to take on along the way. So there's all of these different stops, right? Our data isn't necessarily going to go straight from A to B. It's going to have to, first of all, leave our network through our router, and then might have to go through a different router and then somewhere else and bounce off here and get sent here until eventually it reaches that end IP address that we're trying to reach. And what traceroute does, that ping doesn't do, is it gives us information on how long did this one take and how long did this one take. Right? How much packet loss from here to this one? Every step along the way. It's tracing the route from our data being sent to the data's destination. It is tracing the route. It's in the name. And the only thing you really need to know that's different from Windows is in Windows, the command is trace RT, but in Linux, you're typing in the entire word. It's trace route. TRACEROUTE. Okay? So functionally, everything else is the same with traceroute. It's just the different pronunciation or specific syntax that you have to use there. Other than that, everything's the same as it is in Windows for traceroute. Now, we've got man. The man is basically manual. So if you have any command you're not sure about, let's say I don't know about IP, the IP command, I would type in man space IP, which is the name of the command, and it would give me a manual on that, and I can scroll through and read all about it. Press Q to quit. If I want to learn more about the grep command, right? It would give me a complete manual on the grep command. So that's very useful as well if you are trying to learn about these commands. So that's that. And then you've got cat. So cat here is that command that displays the contents of a text file. That's the command I used before. So here I have my text file, which is test text. If I want to see what that actually has within it, I would say cat test text, and that would print the contents of that text file. And then the next command that we want to know about is top. So top, if I just drag this over here, top provides a real-time view of system processes, including CPU and memory usage, right? So that's going to be super handy. If I type in top, it's going to be this real-time view of my system usage in terms of the CPU and the memory usage, right? So that's actually going to continue to run until I hit Control-C to kill that command. So you can get an idea of what is using most of your system there, right? So that's going to be super, super handy. Now, the next one is PS. So this command displays information about running processes on your system. So if you go here and you just type in PS, you can see information on the processes that are running there, right? And what's going on in your system. So that is, of course, very useful to know as well. Now, the next one we need to know about is the command du. And this is the one that is going to tell us what is using how much space on our disk. So if we want to see, hey, I want to free up some disk space. I want to see how much disk space is being used by what. I would use the du command or the disk use command. So if we hop on over to Linux and I type in du, it's going to give me this information, all right? So I get information on exactly how much space on the left here is being taken up by the particular things on the right. Now, a nice little hint is you can do du flag h to make it human readable. And all that means is, right, it puts it into human readable data here, right? So instead of just being endless numbers, it's 8.0 thousand, okay? So du, basically, long story short, you just need to know it gives you information on how much space is being taken up by what on your disk so you can know what to delete and what to keep. Again, for your exam, just know du shows you how much space is being taken up by what on your Linux system. For your exam, 99% of the time, that's all you're going to need to know. The next command is df. So this shows disk usage information. So if I'm in my system and I type in df, it will basically show me all of this. So the file system and the percentage that I'm using, right? So if you want information on your disk usage, the percentage of what different things are using a certain percentage of your disk, you would use df to find that out. What is the most resource intensive things that you are running in relation to your disk? That's what you'd be looking at, df. Now, and again, nano is what you use to edit text files. So if I wanted to actually edit this text file, I would say nano text. That would bring me into the text editor, and then I would be able to edit. So I can say, hello, I hope you pass, and then I'd say exit, yes to save. I'm going to keep that same name, and now if I cat that, you'll see it's been updated. So that's pretty much what that does. It allows you to edit the text file. So that being said, there is an important tip here. I really want you to practice actually using these, all right? So make sure you practice using these things. Now we're going to be moving on to some configuration files. So Linux has different files, and those files have very particular purposes. For your exam, you just need to know the purpose of each individual file. This one actually doesn't show passwords, but it does give information on your user account. So basically, you just need to know that the password file shows information on user account. So it's a plain text database that is readable by all users. Any information you need to know about a user will be located in the etc/password file. Functionally, that's it. Don't really think about it in any more depth than that. The next one you need to know about, which is related, is the etc/shadow file. Now this one does store encrypted user passwords securely. So this is where the user passwords are stored, in the shadow file. It is only readable by the root user for maximum security. It does contain passwords aging and expiring information. So it tells you when they're going to expire, right? And again, strong encryption. So just know the user information is stored in the password file, bit counterintuitive, and the actual encrypted passwords are stored in the shadow file. Now, the host file, what does this contain? This maps IP addresses to host names, essentially functions as a local DNS lookup table. So before your device goes ahead and consults external DNS servers, it's going to have a look in the hosts file to see any information about DNS. A classic example is your loop back address, which is, you want to communicate with yourself, which is 127.0.0.1. It's going to give information that is in fact the loop back address. So long story short, guys, I want to break it down nice and simple. The host file for your exam, just know, works as the internal first place of reference for any DNS lookup related information. So for your exam, you might be asked a question that says something like, what file can be used to find information relating to DNS, etc., right? In which case it would be the host file. Nail that in your brain, you'll be all right. Next one is the etc/fstab file. Now, this has nothing to do with stabbing. Let's take a look at what this is. This one defines static file system information. We're looking specifically at things like listing out partitions and devices to mount at boot, so your device will know what to mount and what not to mount. Specifies the specific mount points, the file system types, and options. So the fstab, think of it as fstab file system tab, right? Any information that your device needs to know about mounting is going to be in the fstab file. Mounting fstab. That's it. Don't look any more in depth than that. All right. And the next one is going to be the etc/resolve.conf file, or config file. So this is configuring DNS name servers. It contains IP addresses of the DNS servers that you're going to be contacting. So it specifies the search domains for hostname resolution. For example, it might say, hey, the name server is 8.8.8.8, and it often is managed automatically by network services. So again, for your exam, nice and simple. Forget a lot of what I just said, just nice and simple. Resolve.conf file configures DNS name servers. So it is not your internal DNS lookup table. It is actually configuring the external DNS name server that you need to use, and it's saying, hey, this is the IP address of these DNS servers. So once we go ahead and have a look in the host file at our internal DNS, maybe we don't find what we need there, we can go to this one, resolve.conf, and that will give us the IP addresses of the external DNS servers. That's what you need to know, really. Now we're going to move on to some primary components of the Linux system that you do need to know about before we finish up this one. I'm on 23% battery, so let's try to pump through this. You've got your computer, right? Here is your computer, and inside your computer, you have your BIOS. We should all know about that by now. We should all have a rough idea of what that is, right? Your BIOS might have a bunch of different drives to boot from. You might have this drive over here, this drive, this drive, this drive. You set your boot order in your BIOS. Okay, great. That's all the prior information we need. Let's say you've set this drive over here to be the first one to boot. The first thing you need to know about is what the bootloader is. And that is essentially within that drive, there is going to be something called the bootloader, which is this thing right here. And that's basically what is going to be initializing and booting up the operating system. So long story short, the bootloader boots up the operating system. Okay, that is the job of the bootloader. Once the bootloader does that, it boots up Linux OS, right? Congratulations, your bootloader has successfully booted up your Linux operating system. Your Linux operating system, for the sake of this, is contained within this red circle. At the very core is something called the kernel. All right, your kernel is essentially responsible for managing everything inside your Linux operating system. Your Linux OS relies on the kernel. Think of it as like the king. It's managing the applications, managing everything that's going on. But it needs to delegate some of those tasks because it's dealing with a lot. Right? The kernel is dealing with a lot. It's managing every single thing inside that Linux operating system. So it has to hire a right-hand man. And that kernel hires as its right-hand man, systemd. Okay? And systemd's job is to manage the processes after the kernel has loaded. Right? So it's managing any processes that are occurring in your Linux OS. Systemd is managing those processes. So that's the broad overview, right? We've got your drive has to boot up the OS. And in order to boot that up, it's using the bootloader. Once it boots up Linux OS, kernel is managing pretty much everything within that Linux OS. If the kernel is compromised, everything's going to shit, basically. And kernel delegates managing any processes to systemd. All right, so now let's go ahead and take a look at some of the more specific details. That's the broad overview. So let's start with bootloader. Again, the bootloader is a small critical program that resides in a specific location on your storage device. Right, so this is in the master boot record, things to that effect. Its primary function is to initialize the computer's basic hardware, load the Linux kernel into memory. So the bootloader boots up the OS and loads the Linux kernel, all right? And then it transfers control to the kernel. Kernel manages everything in the OS. So if you go over to the kernel now, Linux kernel is the fundamental core component of the operating system. It acts as the crucial interface between the computer's hardware and its software. So again, it manages everything within Linux, all right? It manages essential system resources such as CPU, memory, running processes, device drivers, and inter-process communication. So everything that's happening, it's managing it. But like we said, it needs a right-hand man. So it hires systemd, which is an initialization system and system manager for Linux. What does it do? It is a building blocks of modern Linux distributions. It serves as both the initialization system and a comprehensive system manager. It is responsible for initializing and managing processes after the kernel has booted. It includes starting services, managing daemons, which are just like the name for processes in Linux systems, handling system logging, and ensuring efficient boot processes throughout parallelization, not paralysis. So just keep in mind what we went through here, right? Bootloader loads up the Linux OS. Within Linux OS, kernel is responsible for everything, but the systemd is responsible for managing processes and initialization. Hopefully that makes sense, guys. Again, way more detail in the learning guide, which you can see here. It really breaks it down, but at a large scale for you, that's what you need to know. Finally, the last thing we need to know before my computer goes kaputzi is we need to know about the root account overview. And you just need to know that the root account is like the maximum power account. It can do everything and anything. It is the super user. It has unrestricted administrative privileges. It's basically the administrative account, but on Linux. The root account is like the administrative account. It can do absolutely anything. It bypasses all file permission restrictions. It is the king. Which is why sometimes if you need to perform an action that requires a particular amount of power or permissions, you might need to go and act as the root account. So guys, with that being said, we are going to move into some practice questions. So before we get into these practice questions, will my battery make it? I sure hope so. Let's find out. The first question reads, a user needs to view the contents of a directory, including hidden files that start with a dot. Which command would they use? Is it A, ls with the flag L, B, pwd, C, ls with the flag A, or D, mv? Pause the video if you need more time. Your answer is coming in 3, in 2, in 1. It is C, lsa. So if you want to see the contents of a directory, you are using the ls command, and the A flag is the option that allows you to see even hidden files. Have a read through the other ones here, but I'm going to keep this moving on a roll because it's already taken a little longer than I would have liked it to have for this video. The next question reads, to display the full path of the current directory, which command should a user execute? A, ls, B, cp, C, pwd, or D, cd? Your answer coming in 3, in 2, in 1, and it is C, pwd. So print working directory will show you what directory you are currently in. Have a pause and read the other ones, but that was the answer. Hopefully we got that right. Next question reads, an administrator wants to change the owner of a file named report.csv to the user John. Which command would they use for this? A, chmod 755 report.csv, B, chown John report.csv, C, mv report.csv, or D, find report.csv? Your answer coming in 3, in 2, in 1. It is B, chown. So you've got 2 ch commands. You've got chmod, which will modify the particular permissions of a file, but then you've got chown, which will change the owner. So it's important to know the distinctions between those two, how they work. That one might have been a bit tricky. Hopefully we got that right. All right, moving on to the next question, which reads, an administrator needs to execute a single command with super user privileges without fully switching to the root user. Which command allows for this to happen? Is it A, su, B, sudo, C, df, or D, top? Ooh, your answer coming in 3. Pause the video if you have to. 2, 1. It is going to be B, sudo. If you need to act as a super user for one command, you're going to say sudo followed by that command. All right. Read through the other options there. Hopefully we got that one right. Okay. Next one reads, on an RPM based file system like Fedora, which command is used to install a new software package? Is it A, apt install httpd, B, dnf install httpd, C, du, or D, cat? Ooh, pause video if you need more time. Your answer is coming in 3, in 2, in 1, and it is going to be B, dnf. So you've got 2 different ways to install packages. You've got apt, which is the package manager for Debian-based systems such as Ubuntu, and then you've got B, which is DNF install, or DNF, which is the default package manager for RPM-based Linux distribution. Basically, for your exam, just know that you would use apt for Debian-based systems and DNF for RPM-based systems or distributions. All right, that's largely what you need to know. Okay. Next question reads, to track the network path an IP packet takes from your computer to a destination host, which command would you use? Is it A, ping, B, IP, C, traceroute, or D, dig? Pause the video if you need more time, but your answer is coming in 3, 2, 1. It is, of course, C, traceroute. I'm sure we all got that one right. Guys, we know what traceroute does by now. So, next question is non-existent because that's all the questions. Okay, your next thing that I want to talk about is if you enjoy this content, guys, and you do in fact want to get your hand on a learning guide that has helped this person pass, 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 this person get almost full marks and move on to the network plus this person pass, then you can head over to journeytocyber.com. I've got notes and practice questions all broken down by exam objective, so you get questions specifically for that exam objective, notes specifically for that exam objective, and it is a really good way to organize your learning and make sure you're actually prepared, which is why so many people pass with these resources. It's not just me dumping random practice questions on you. It is organized, well-constructed method of learning that will really make sure you're ready for the real thing. So with that being said, you also get 3 full-length practice exams with performance-based questions at the end, and you get some videos where I show you how to study effectively and also how to tackle multiple choice questions if you get confused on the day. So if that sounds good to you, journeytocyber.com/1202. Link is also in the description and the pinned comment below. Other than that, guys, I'm going to leave you to it, and I will see you in the next one.